I'm Jessitron, and I'm excited to talk about principles of collaborative automation. Today, I have 4 prerequisites of collaboration and 3 precautions or ironies of automation. These principles come out of the resilience engineering community and studies of collaboration in humans. But we don't only collaborate with humans. We work with computers, and we can change the computers. So our systems are collaborating with both people and automations. And the automations that we create for ourselves are the ones I'm particularly talking about today. Because development teams are special. We're unique. I define team as everyone required for me to be successful. And I define success as a developer as impacting the lives of humans by operating useful software. For me to succeed, I need some people, some of them are even close to me on the org chart, and I need that software to be running. I need my software to be operating in order to impact the humans. So the software, the running instances of the software are part of my team and their databases and their servers, and also all of the tooling that it takes to get that software into production and to make sure it's still working okay once it is. All of this is necessary for me to achieve my goal. So all of this is part of my team. This is a socio-technical system of humans and software, both the software that we build and the tools that we put in place for this. And it's a system that grows with increasing learning. So, of course, we learn from each other as people, but also my software is learning from me because I change it, and I'm learning from it. Every time it throws an exception, or maybe it gives some log messages, it changes some data in production, I learn from my software. And I'm learning from my tools. First of all, I can't see what's going on in my software without the tools, so I totally need them in order to learn. But also, a test failed. I learned something from that. And then hopefully my tools are learning from me because I'm changing the tests. I can improve my build pipeline. I can automate linting, that kind of thing. And then I'm writing queries in my log aggregator, and I'm making dashboards for my metrics. This system is all about the learning. And as Andrew said this morning, learning is the only sustainable advantage, so this is important. There's a word for this particular kind of system, and it's symathecy. Sorry, it's a hard word, but it's a useful word. Symathecy from the Latin sim together and mathesy learning. This was coined by Nora Bates, an anthropologist. And it distinguishes from a mechanical system, which, while it might have a lot of complicated relationships going on, the pieces are holding still. They're staying the same. We are not the same from day to day. We're constantly learning and growing. And we're constantly learning and growing our automations, which is important because there's an obstacle to this learning in our particular socio-technical system. It's called the line of representation. Because see, if I want to learn from you, well, I can talk to you, and I can tell you stuff, and maybe I can tap you on the shoulder if we're in the same office. But the people on this team cannot just look down and see what's going on in the software and rearrange it like objects on the table until Tron is a thing. We are limited to our screens and keyboards and buttons. So the line of representation is a crucial choke point in the flows of learning here. Our code editors are on the line of representation because we can see the code. That helps us figure out what it's going to do and change the software. And of course, our deploy buttons and our test reports and our log aggregators and SSH at the crudest level is on the line of representation. And because our tools are poking holes in this barrier to learning, I'm really focused on these automations as important collaborators in our team. Okay, 4 prerequisites of joint activity. And first of all, joint activity is defined as we have a common goal that we're all working on together, and our tasks are interdependent. So if we say, let's all have dinner together, and I say, okay, you make the meatloaf, you make some mashed potatoes, I'll cook a pie, we'll meet here at 6 p.m. That's coordination, but it's not joint activity. If, on the other hand, we're sharing a kitchen with one oven and counter space and the same ingredients, and maybe we're washing each other's dishes, that is joint activity. Now, in software, our tasks are hella interdependent. When we're all working on the same system, we are totally getting in each other's way or helping each other, one or the other. So these 4 pillars of joint activity can help us do that well, and they apply to our tools. Okay, the basic compact. This is an agreement, usually unspoken, that we're all going to work together until we say we're not, and we're going to work on making sure that continues to work well. So, for example, with people, this means that if you're not going to come to work today, you call in sick. Hey, I'm not participating today. You don't just ghost on your company, you resign. But it's smaller than that too. It's things like you show up at stand-up and you're like, look, I was up all night with a sick kid. I'm really cranky. If I yell at you today, it's not you, it's me. I am inhibited in my collaborative abilities today. A counterexample of that, out of aviation, okay, there's this plane flight, right? And there's a fuel leak. And it just happens that the crew notices that the fuel is going down on the left, even though the engines are pulling from the right, and they're like, oh, that's weird. Let's go look out the window. And sure enough, there goes the fuel. And then they can see that, oh, the autopilot has been responding to the imbalance in the weight of the plane by turning the rudder thingy. And it's way over here. And eventually, the autopilot would not have been able to compensate for the out of balance, and then it would have been too late. But it wasn't telling anyone that it was trying. So here's a secret of collaboration. Don't try harder. Or don't just try harder. Talk to your team. Tell them that you're struggling. Okay, in software, an example of this is health endpoints. Our software needs to be able to tell us if it's doing okay, but not just yes, no, green, red. No. The health endpoint should say, hey, I've been up since so-and-so, and I'm serving requests at this rate, and my downstreams are doing this thing, and they're responding like this, and oh, one of them's down, so I'm on the fallback, and I have this many database connections. There's a higher resolution of that, because that helps us collaborate. More on the basic compact. It's that alignment of goals, and it's also, we're going to tell you if you stop, and it's also, if we have trouble with the collaboration, we're going to stop and we're going to recover. So we're going to signal each other whether we're communicating correctly. The basic compacts means we need to surface weaknesses, both in people and software. So don't swallow errors. Oh, on one team we had the ostrich exception handler, which would stick its head in the sand. That, not recommended. So maybe you don't want to display an error to your user, but display it to the people on the team. Display it to the operators, because humans are really good at handling everything else that we hadn't planned for yet. That's our job, so let the software fall back to that. This implies that we don't rely on our team members to be available 24/7. I don't count on you to answer my phone call at any given time. And I don't count on an instance of my software to continue running and be responsive forever. No, we look at it and we're like, are you okay? No, new pod. And with people, when we might answer Slack messages directed at a person who's sick today, we compensate for each other's weakness, both in software and in humans. And the effect of that is that from outside the team, the organization can rely on us. So I work with you so that 24/7 somebody is answering pages. And we work with the software to restart the damaged instances or whatever their problem is, we don't even care. Work with inside the team so that outside the team it can be relied on. Here's another example. If your software uses Kafka and you operate that Kafka, can you rely on that? You want to think you can rely on it, and sure enough, you'll be just fine until you're not. And then you're Googling everything and trying to figure out how to recover those lost messages because your queues were full or whatever the heck happened. You have to work with that software. On the other hand, if you pay for Kafka as a service, then when it goes down, you talk to a human and they fix it. Because with humans involved, a system can be resilient and reliable. So you can't rely on the software you operate, you work with it, but your company can rely on you collectively as a team. All right, so that's the basic compact. The next thing we need is to be mutually predictable. We need to have a general idea of what our team members would do, and it's probably the same thing we would do in the same situation. And if not, it's time to restore some shared context. So in stand-up, we say, oh yeah, I'm working on this thing, I'm going to add a new table, and that gives other people the opportunity to say, you're working on what? Why are we doing that again? And to pick up, if you're surprised by your coworkers or your software, that's a breakdown in mutual predictability that we can restore. Counterexample, I send a lot of texts that start with kinda. That's not me, that's autocorrect. I have a daughter named Linda. Damn it, Apple. So in like not self-driving cars, but driver-assisted cars, right? They've got this thing where if you're too close to the car in front of you, it'll hit the brakes. Okay, well that's fine unless you're trying to pass that car. So what you have to do is signal for the lane change so that the automation can predict what you're going to do and say, oh, you're going around. I'm not going to slam on the brakes for you, thanks. That's important. Trivial example in software, the other day I installed Git on a computer and it's got the little style installer and it's like, okay, I'm going to ask you some questions and then I'm going to tell you what I'm going to do, then I'm going to install the thing, then I'm going to give you a summary. I mean, it's boring, but it's kind of comfortingly predictable because predictability breeds trust. We need to be able to understand the state and the actions and what is about to happen of our software because then we can trust it. What this means is I don't want any AI in my automations that I use. Now, you might have AI in your production software because in your production software, you can justify working hard on it to get past the uncanny valley of what the F did you just do? What? Why? We've got an automation at the moment that's not following this rules. It's using NLP, natural language processing, to yell at me when I don't make a commit message in the past tense. And so I made a commit message the other day. Check that clients are connected. And it's like, your commit messages should be in present tense. And I'm like, but no, it had the word connected in it, and that's past tense. Okay, no, this is not helpful. I do not want my automations to try to be smarter than me. Hello, I'm still in the loop. Call me if you need me. Machine learning is an example from production. There was a credit card processor, and there were a bunch of transactions being marked as fraud from the Netherlands, and it's like, Dutch, they're pretty trustworthy. What's the problem here? And so once a developer went to the trouble of modifying the machine learning procedure so that they would tell you which rules fired, which rules were highly rated and caused this one to be rejected. It was like, oh, well, the country code is between 34 and 36. Well, it turns out that country code 34 is like Nigeria, and 36 is like Liberia, and 35 is the Netherlands. So once you see that, you can say, yo, machine learning model, that is an enum, not an amount. Quit your range comparisons. So our software needs to be accountable in the sense that it needs to tell the story of what we're doing. Just like we're accountable to each other not to be perfect, not to be there every day, but to tell the story of why. Okay, even better, I like it when my automations can teach me what's going on, actually increase my knowledge. So if a new person comes to the team at Atomist and they push code, in the Atomist delivery system, our delivery machine looks at that push and it decides, okay, we're going to do this and this and this and this and this and this, and it puts them all in a list, and then I start turning green. But it teaches people what happens and how our deploy gets done. And I could make this even better, and I will, but still, it's great. I really want my automations to teach. That's the best. Okay, now that we're mutually predictable, we can be mutually directable. And that means we can influence each other. We can be like, hey, I need the oven in 15 minutes. Could you get your stuff in now or out? So mutual directability means that we can influence each other's plans once we know them. So in stand-up, I might say, I'm going to create this new table, and you might think, how many link records are you going to have? And can we talk about that? And we can decide together on a better plan. A counterexample is if you walk into an office and you apply for something and the person behind the counter is like, computer says no. You've seen that. You realize the computer is in charge in that situation. And that's not cool. More on that in a minute. A positive example in production software. I used to work at this insurance company, and we had this system. It was written in Java, and it had a bespoke ORM from around 2000, and it was crap. It was wrong. The caching just didn't work. But it lasted years longer than it otherwise could have because it had great admin screens. So when a user calls in, because developers are first-line support here, and they're having trouble creating their quote, I can go into that screen, I can see all the cache entries for each user, I can clear the cache, I can change the values of the cache, I can compare it to the database, whatever I need to do. It was highly directable, just took a lot of manual direction, but that was still a win, and I want that in my software, although I do want the ORM to work better. Okay, more about mutually directable. The thing is that our automations should present and explain choices, not enforce them. Navigation is a great example. It used to be that when you got navigation from your car, it told you where to go, and that was the opinion, and that was all you got. But these days, in Google Maps, it gives you the happy path. Here's the blue one. I think this is the fastest. But oh, here's some other ones you might take. And look, this is the traffic along that route, and that's why it takes 8 minutes longer. I can make an informed choice. It's not forced on me. Also in Gmail, I really like the new feature where it suggests phrases that you're very likely to type, and you can hit tab and it accepts them, or you can just keep typing. Unlike autocorrect, which ducking goes back and changed what I already wrote. So frustrating. An example from Atomist. So our automations, one of the built-in ones pops up, hey, you created a new repository. Would you like to create a Slack channel to receive notifications? And the most common thing that we want to guide people toward is to create a new channel. So there's a button for that, but there's also a drop-down for things you're less likely to do. And there's text at the bottom for everything else. The easy thing is, the best thing is easy, and everything else is possible. That's important. There's a weird property of negotiation that the person with less flexibility has more power. So if I'm a vendor and I want to sell you my software, and you're a manager, but you're not the CEO, you don't send the CEO to the table because that would reduce your power. The manager is authorized to spend $20,000 a year. If I want more than that, well, maybe we can meet again next week after he goes and talks to somebody. But I have responsibility as the salesperson. I have numbers to meet. So the manager with less flexibility has more power in that negotiation. It's kind of counterintuitive, but that is how it works. And that is what we don't want in our automations. We don't want them to be so inflexible that they have the authority in what we can do. So keep the human in charge, especially when it's automations that we have the power to change and we have the power to do the things that they're doing if they don't know how to do it right. A good example of directability and predictability is programs like Make. A lot of them have a dry run. And so you can ask them what they're going to do, and you can look at that, and then you can say, yeah, okay, I want you to do that, and actually run it without the dry run flag. Or you can just run those commands yourself if you only wanted a subset of them. I really like that. Separate decisions from implementing them. Okay, that's mutual directability. Last, but definitely not least, because this one's the hardest, and it's the prerequisite for everything else, is common ground. So common ground is the stuff that we all know, and we all know that we all know it. And we all know that we all know that we all know it, and we all know that we all know it, and so on. Now, this is mathematically impossible in the presence of uncertain message passing, but humans, we're fine. It's close enough. So you have a meeting, and you assume that everyone in the meeting heard what was said, and so that's common ground. Now, if I was sleeping in the meeting, then, the next day I go to do something, and you might be like, Jess, I thought we said in that meeting we weren't going to do that anymore. And I'm like, oh, we did? Oh, thanks. I must have been asleep. So we restore common ground. That's part of the basic compact. We restore common ground when we notice that it's missing, because we don't get it perfect, mathematically impossible. We just repair it when it fails. Okay, but there's another thing to common ground. We don't share all of our knowledge. There's a reason we have more than one person on the team. We can't all know everything. So I stream on Twitch regularly, and my coworkers could hypothetically all watch and know exactly what I'm doing. But of course they don't. They have their own work to do. Part of the common ground is being careful with each other's attention. The counter example of this is in hospitals. If a nurse brings up a patient record, and every time they do this, they get 6 pop-up alerts. Okay. Let me get my job done. So if your alert about 2 medications that might interfere with each other and cause an aneurysm is the same importance level as, oh my God, the room is out of sheets, then, people aren't going to see that. We have to respect each other's attention and be careful. So fix those alerts that go off that you don't do anything about. Otherwise, you'll never get the good ones. A common ground with software is violated, or we can identify a failure in it every time we see a bug. We didn't think it worked like that. I observed that it's working like that. Okay, what is going on here? I really like how in modern web apps, there's layers of human-readable code and text that we can establish common ground on. So I can look at the TypeScript code, I can look at the JavaScript that compiled into, I can look at that same JavaScript in the browser, I can look at the React tab in the Chrome debugger and see that structure. I can look at the HTML, I can look at how the CSS has been applied to the elements, I can look at the JSON that's going back and forth from the server. All of these are opportunities to reestablish common ground when we recognize that it's broken. I really like that. Common ground is super important because the thing is, complexity is here to stay. Complexity is good. John Allspaw has a beautiful thing about success begets complexity, which begets success, which begets complexity. If you can get it technically simpler, then keep the technology simpler while you can. But you want complexity in the business domain. That's how you're improving the lives of humans. By taking this complexity out of their brain and putting it in the software, by doing harder, more complicated things. And when you succeed at that, then you get more customers. You have to worry about backwards compatibility. Good luck keeping that simple. And you get more customers that need more features, and so you get more feature interactions, but that makes your software more useful, so you get more success. Okay, complexity is not bad. Complexity is great. It's what makes our software useful. So stop acting like we can eliminate it completely or like that's the goal. Instead, add more feedback. More feedback so that when we need to figure out what's going on, we can. We think now about the user interface, but the users aren't the only people who interact with our software. We do. So consider the operator interface. Because how we interact with our software, how friendly it is to us and how helpful, that matters. As an example, I was pairing with Eric Evans the other day, and he's got this little web app that he's working on for personal purposes. And when he goes to develop this web app, the first thing he does is make this breadboard page. And every function that he adds to the flow of the web app, so there's like 4 different steps to Google off. As he's figuring that out, there's 1 button each. And then the flows of processing the emails, each get a button, and in between they can report on different stuff. He built the operator interface as he's developing it. This is fantastic for debugging and for troubleshooting. And oh my gosh, if you build this first, it helps a lot with development too. Your experience matters. If you're having trouble debugging your software, change your software. We have that power. Okay, and consider the communication is not atomic. It's not one message at a time. It's always a conversation. In particular, error messages are the perfect time to tell your user or you as an operator what to do differently, to make suggestions. Evan Czaplicki, the creator of the Elm programming language, says that if you get a compile error and you don't know what to do about it, that is a bug in the language. Because the purpose of the compiler is to help you get it right, and if it's just making you mad, that's not right. That's not his job. So let's rename them to help and guidance messages. I love really good error messages. They make me so happy because my real job as a developer is to get new error messages as fast as I can. Okay, common ground is essential and it's really hard to maintain. This is what limits our team size, is keeping all this coordination. Together, these 4 pillars of joint activity apply to us, they apply to our software, and now it is time for a gratuitous cat picture. This is Odin and Pixie helping me with talk prep. And now it is actually time for the 4 ironies of automation. These are things that you would think automation would make easier, but it actually makes harder. The first one is, if you think by building automation, you're gonna be able to hire cheaper humans to run it, you're wrong. Because in order to check whether software is working correctly, I have to understand everything it does and more, and be really good at problem solving, and I need a ton of feedback. What you get out of automating is not cheaper humans, it's not less human. What you get is stuff you couldn't do before, because the computer is faster than the lizard brain. And this lets you reply to applications in seconds instead of 1 to 4 weeks. This lets you run Patriot missiles and fly fighter jets at all. So automation is really powerful, but don't think it's going to save you money. It's going to let you do things you couldn't do otherwise. The next one is that you want to think about the happy path. We love to think about the happy path, and we're like, well, that's 99% of code executions. Yeah, but it's one of hundreds of different paths through your codes, just one. The beauty, when we're making automations for ourselves, we really don't have to handle those cases. All we have to do is make them non-catastrophic and fall back to a human. Because I did this by hand before, I can do it by hand again, and then I can automate the edge cases as I need them. This is why, one reason why making automations for ourselves is way, way, way cheaper than making software that someone else has to run. Watch out that if you cover those 99% of cases, that 1% can get harder because it's not top of mind anymore. So if you operate Kafka, then when Kafka goes down, you're like, why do I have to think about this? And you're like learning new concepts from Google. Whereas if I pay someone to operate Kafka and it goes down, well, that's fine. Somebody's Kafka is always going down. So they're all day, they're in this mode of troubleshooting and repairing Kafka. So they're in that headspace, and that's a win. So be careful making it easy for yourself most of the time. The last one we've already talked about. The more flexible party has more power, or the less flexible party has more power. So counterintuitive. So your automations should make the best path easy, but never mandatory. Okay, as developers who can change our tools, we have the special power to overcome these ironies of automation. And we can let the humans do what we're good at, which is the social skills, which gives us, why are we doing this anyway? And the novelty and problem solving for every case that we didn't think to program into the computer. And then we can move work down into the technical half of the system to get speed, power, and consistency. Keep those flows of mutual learning going, and we'll keep getting better, because we're never done. Our system is never perfect. Your coworkers are never going to be perfect. Your automations are never going to be perfect. So make them collaborative. A lot of thinking went into this talk, very little of it mine. Here are some references. Thank you.